Today we're doing section 2.2, day 3, still just discussing quadratic functions, but now we're going to apply this to word problems. So here's going to be your general picture of a parabola. We're going to assume when we're doing a word problem that the parabolas are going to be opening down like this because there will be some kind of trajectory and it's traveling. So in the word problem, if it ever is referring to a max height, that means it's referring to the y part of the vertex. And a lot of times I tell students just to draw a picture and think about it. So your max height would be located right there. And you have this drawing on your picture. The point of impact when max height is achieved is the x part of the vertex. Okay, so if they're looking for the point of impact that matches the max height, that would be the x part of the vertex. And if they're talking about the distance an object traveled, that would be talking about your x-intercepts. Okay, so let's go through a word problem. I recognize that you probably don't have calculators at home, so I'll just do all the calculations for you. So it says when a football is kicked, the nearest defensive player is 6 feet from the point of impact with the kicker's foot. The height of the punted football, f of x, so f of x is measured in feet, can be modeled by the following equation, where x is the ball's horizontal distance in feet from the point of impact with the kicker's foot. So letter A says, what is the maximum height of the punt and how far from the point of impact does this occur? So the key word right here is maximum height. That means we're referring to finding the vertex. So we know we need to do x equals negative b over 2a. So in this instance, it will be negative 1.18 over 2 times a negative 0.01. And when we do that calculation, we end up getting 59 feet. Now, because this is an x value, this would be how far from the point of impact. So this would be 59 feet from the point of impact. So it is important when we're doing these word problems that you label what your answers represent. Now I need to plug 59 in, so I have negative 0.01 times 59 squared plus 1.18 times 59 plus 2. So when I do this in the calculator, and obviously tomorrow we'll practice with the calculator, we get a y value of 36.81. And this is also feet, but this is going to represent our max height because it is a y value. So just kind of think about when you find your vertex, which one's an x, which one's a y, and then make sure you indicate that in your answer. Letter B says how far from the nearest defensive player who's 6 feet from the kicker's point of impact reach to block the punt. So for this one, all we have to do is plug in 6 feet. If I want to know any given height at a certain distance, you just plug that in. So I have negative 0.01 times 6 squared plus 1.18 times 6 plus 2. And again, you just use your calculator, you would type this all in, and we get 8.72 feet. So I'm actually going to do letter C on the next page just so we have more room. So it says if the ball is not blocked by the defensive player, so we're assuming no one touches the football, so it's going to be punted, it's going to travel, and it's going to land on the ground. We want to know how far down the field will it go before hitting the ground. So this would be the distance that it travels. So that's going to match up with our x-intercepts. And the way we do that is you set these equal to 0. So obviously this is not going to be factorable, so this will be quadratic formula. So I have negative 1.18 plus or minus the square root of 1.18 squared minus 4 times a negative 0.01 times 2 all over 2 times a negative 0.01. And again, just like we do this by hand, I always tell my students to do the part underneath the square root to keep things consistent when we're doing this in class tomorrow. We're going to round to 4 decimal places. So the value I get underneath the square root would be 1.4724, all over negative 0.02. Now we're going to actually take the square root of that decimal, and again, rounding to 1 or 4 decimal places. So that will be 1.2134, all over negative 0.02. Now from here, we do two things. I do negative 1.18 plus the 1.2134, and then I do negative 1.8 minus, and we divide both those values by negative 0.02. So the two answers I get are 119.67 feet, and I get the answer of a negative 1.67 feet. Now, because we're talking about a real-world application, we're talking about distance, this answer gets tossed out, and the positive answer would be my final answer for that problem. So the last thing I want to go over just to kind of introduce is a maximizing or minimizing problem. We will do a whole other lesson on this for tomorrow evening. So just real quick going over the strategy. Number 1 says read the problem carefully and decide what quantity is going to be maximized or minimized. Use your conditions of the problem to express the quantity as a function in one variable. You're going to rewrite the function in the standard form, and then you're going to find the vertex, and that's all number 4 is stating, is that you find the vertex. So let's go through one problem, and we'll kind of reference back to this. So it says, among all pairs of numbers whose difference is 10, find a pair whose product is small as possible. So what we're trying to maximize or minimize is a product of two numbers. I don't know what those numbers are, so we're just going to call them x and y. You can call them anything you want. Now we're going to use the conditions of the problem. So step 2 says use the conditions of the problem to write a function. So these two numbers have a difference of 10. So I know x minus y is going to be equal to 10. Then it says to express the problem in standard form. So what we're going to do is we're going to solve this equation, the one that has the number, for y. So I have negative y equals negative x plus 10. We're going to divide both sides by this negative 1. And we get y equals x minus 10. And now I'm going to take this and I'm going to plug it into what we're trying to maximize or minimize in this case. So y is going to be replaced with x minus 10. I can distribute this and I get x squared minus 10x. So now we've completed step 3. I wrote an equation, a quadratic equation in standard form. So lastly, step 4, maybe I should label these steps real quick. So let me change my color. This was step 1. Writing the equation was step 2. Getting in quadratic form was step 3. All right, so step 4, find the vertex. So I have x equals negative of a negative 10 all over 2 times 1. So I have 10 over 2. So I know x equals 5. And now I know that x equals 5, I'm going to use this fancy equation that says y equals to find what y equals. So I have y equals 5 minus 10, so y equals negative 5. Now, the question doesn't say to find the value of the two numbers. The question says what is the minimum product. So I would do 5 times negative 5, and my minimum product is a negative 25. So we are definitely going to do more practice a whole other evening on this, so don't worry if you don't understand this quite yet.